When most people think of a supervolcano in the United States, one name comes to mind almost instantly. Yellowstone, that vast sleeping giant beneath Wyoming, has become a household word, the subject of countless documentaries, disaster movies, and late-night internet rabbit holes. And those who dig a little deeper often discover a second name, one that geologists take very seriously. Tucked beneath the eastern edge of California, near the ski town of Mammoth Lakes, it is called the Long Valley Caldera, and it is one of the largest volcanic systems on the continent, a place scientists watch closely, monitor constantly, and study with an almost obsessive attention. But here is what almost nobody talks about. There is another one, a third great volcanic system, hiding in plain sight in Northern California, far from the famous names, sitting quietly beneath rolling hills, vineyards, and one of the most productive energy sites on the entire planet. It has produced enormous eruptions in the deep past. It sits atop a body of molten and partially molten rock that scientists believe is still there, still hot, still capable. It shows signs of restlessness that would make headlines if they happened anywhere more famous. And yet it receives a fraction of the public attention, a fraction of the fame. And to most Californians, it is completely unknown. Millions of people live within reach of it and have never heard its name. This is the story of that hidden giant. In this video, we are going to explore what a supervolcano actually is and why they are among the most powerful forces on Earth. We are going to look at the two California systems people occasionally hear about, and then we are going to turn our attention to the one that almost no one is watching, the volcanic field in Northern California that quietly powers a huge share of the state's clean energy while concealing something far larger and far more dangerous beneath it. We will examine the evidence for what lies below, the warning signs it has shown, what an awakening could mean for the region and for the millions who live nearby, and why, despite all of this, it remains so overlooked. This is not about spreading panic. It is about pulling back the curtain on one of the most fascinating and underappreciated geological secrets in North America. Stay with me until the end, because once you understand what is really sitting beneath those peaceful hills, you will never look at that part of California the same way again. Hashtag, what a supervolcano really is, before we can appreciate the hidden giant. We need to be clear about what we are actually talking about, because the word supervolcano gets thrown around loosely. And the reality is both more precise and more astonishing than most people realize. When you picture a volcano, you probably imagine a tall, cone-shaped mountain, something like the classic peaks that dot the Pacific Northwest, with a crater at the top that occasionally spews lava and ash. Those are real volcanoes, and they can be deadly. But a supervolcano is something entirely different, and in many ways it does not look like a volcano at all. A supervolcano does not build a neat mountain. Instead, it is defined by the sheer scale of what it can erupt. The largest eruptions in Earth's history, the ones we call super eruptions, expel such an unimaginable volume of material that the ground above the emptying magma chamber collapses inward, forming a vast crater called a caldera. These calderas can be tens of miles across, so large that if you were standing inside one, you might not even realize it, because the far walls would be over the horizon. The engine behind all of this is magma, molten rock stored in enormous reservoirs miles beneath the surface. In the systems that produce super eruptions, this magma tends to be thick, sticky, and rich in dissolved gases. The kind of magma that does not flow gently, but instead traps pressure, like a shaken bottle of soda with the cap screwed on tight. Over thousands or hundreds of thousands of years, this reservoir can grow, recharge with fresh molten rock from below, and build toward a threshold. When it finally releases, the result is not a lava flow you can outrun. It is a catastrophic explosion of gas, ash, and pulverized rock, sometimes accompanied by scorching avalanches of superheated material that race across the landscape, and towering columns of ash that can be carried for hundreds or even thousands of miles by the wind. To be clear, the very largest super eruptions are rare, occurring somewhere on Earth only every so many tens of thousands of years, and the odds of one happening in any given human lifetime are low. But the systems capable of them do not simply vanish between eruptions. They persist for enormously long stretches of time, going through cycles of quiet and unrest, of swelling and settling, of producing smaller eruptions in between the giant ones. And the key insight, the one that matters for our story, is this. A volcanic system does not have to produce a world-ending super eruption to be extraordinarily dangerous. Even a modest eruption from one of these systems, occurring near populated areas, could be a catastrophe. And the systems that have produced super eruptions in the past are exactly the ones scientists most want to keep their eyes on. Hashtag the famous one beneath Long Valley to understand why the hidden giant is so overlooked. It helps to understand the one California supervolcano that does get attention, because it shows what a well-watched system looks like. Along the eastern side of California, in the shadow of the towering Sierra Nevada, lies the Long Valley Caldera. It is an enormous bowl in the landscape, formed when a truly colossal eruption blew out of the region hundreds of thousands of years ago. An eruption so vast that it blanketed much of what is now the western United States in ash, and emptied a magma chamber so completely that the ground collapsed to form the caldera we see today. That single ancient event ranks among the great volcanic catastrophes preserved in the geological record of the continent. Long Valley is not dead. It is what scientists call dormant but restless. Over recent decades, it has shown episodes of unrest that captured the attention of geologists and the public alike. The floor of the caldera has risen measurably, swelling upward as pressure builds beneath it. Swarms of earthquakes have rippled through the region. In places, trees have died where volcanic gases seeped up through the soil, suffocating their roots. These are the classic signs of a living volcanic system, one that still has magma beneath it and still stirs from time to time. And because of the popular ski town that sits right in the region, and because of the dramatic nature of these signs, Long Valley has become one of the most intensively monitored volcanic areas in the country. Instruments track its every tremor, its every millimeter of uplift, its every exhalation of gas. Scientists understand it about as well as any volcano can be understood. In short, when it comes to Long Valley, people are watching, which makes the contrast with our hidden giant all the more striking. Hashtag the giant nobody names now travel to the opposite corner of California. Far to the north and west, away from the desert and the high Sierra, into the green, rolling country north of the San Francisco Bay Area. This is a land of oak, covered hills, vineyards, hot springs, and a large, beautiful lake nestled among the ridges. It is peaceful, rural, and to the millions who drive through it or vacation there, utterly unthreatening. And yet beneath this gentle landscape lies one of the most remarkable and least appreciated volcanic systems in North America. This is the Clear Lake Volcanic Field, and it is the hidden giant of our story. Unlike the neat cone volcanoes people imagine, this is a sprawling field of volcanic features, a region where molten rock has repeatedly risen toward the surface over a long span of geological time, building domes, spreading lava, and blasting out ash across the surrounding country. It is young in geological terms, having been volcanically active in the relatively recent past, with eruptions that occurred well within the span of human existence on Earth, not the distant hundreds of millions of years ago that many people assume when they think of volcanoes, but within a time frame that geologists consider recent and therefore significant. What makes this field so extraordinary and so quietly alarming is what lies beneath it. The evidence strongly suggests that there is a large body of magma, or hot, partially molten rock, sitting in the crust below this region. Scientists infer its presence from several lines of evidence, and the most spectacular of them is sitting right there for anyone to see, if they know what they are looking at. Because directly adjacent to this volcanic field is one of the most incredible energy resources on the planet, a place where the Earth's internal heat comes so close to the surface, and is so intense that humanity has tapped it to generate an enormous amount of electricity. Hashtag the heat that gives it away. To understand why scientists believe there is something enormous simmering beneath Northern California, you have to understand the geothermal marvel that sits on top of it, because it is the single greatest clue to the giant below. In this region lies what is widely regarded as the largest geothermal energy complex in the world, a sprawling network of wells and power plants that draw on the extraordinary heat rising from deep within the earth. Steam, produced when water meets the intensely hot rock below, is harnessed to spin turbines and generate a remarkable quantity of clean, renewable electricity, enough to power a substantial share of a region's needs. It is a genuine engineering triumph, one of the crown jewels of renewable energy, and it is operated for decades as a quiet, reliable workhorse of the power grid. But stop and think about what this actually means. For heat of that intensity to be present so close to the surface, over such a large area, there must be a tremendous source of it below. Rock does not get that hot on its own. Something is heating it, and the most compelling explanation is a large reservoir of magma, or recently molten rock in the crust beneath the region, a lingering hot heart that is not yet fully cooled and solidified. In other words, the very thing that makes this place so valuable as a clean energy source, the incredible heat, is also the fingerprint of the sleeping volcanic system beneath it. The power plants are, in a sense, sipping from the warmth of a giant. Every kilowatt of electricity generated there is a quiet reminder that something very hot and very large is still present below. And this is the heart of the paradox. This region is famous, but for the wrong reason. People know it as a marvel of green energy, a success story of renewable power. Almost no one thinks of it as what it also is, the surface expression of a major volcanic system with a substantial magma body beneath it. The fame of the power plants has, in a strange way, hidden the volcano in plain sight. People see the steam and think of electricity. Few see the steam and think of the molten rock that makes it possible. Hashtag why nobody is watching. So if this system is so large, so young, and so clearly still hot beneath the surface, why does it receive so little attention compared to Long Valley or Yellowstone? The answer is a combination of factors, and understanding them reveals something important about how we perceive risk. The first reason is simply appearance. Yellowstone has its dramatic geysers and boiling mud pots, and its status as a beloved national park, drawing millions of visitors who marvel at its volcanic wonders. Long Valley has its towering caldera walls, and its famous ski resort, and its headline-grabbing episodes of unrest. These places look and feel volcanic, the hidden giant of Northern California, by contrast, wears a disguise of pastoral calm. Its landscape is gentle and green, its most dramatic feature a placid lake and some hot springs that read more as a relaxing getaway than a warning sign. There is no towering peak, no obvious crater to focus the imagination. The danger is subtle, spread out, and easy to overlook. The second reason is that the system's recent behavior has been quiet. It has not produced the kind of dramatic, sustained unrest that thrusts a volcano into the news. There have not been the same high-profile swarms of alarming activity that made Long Valley famous. And human attention, both public and scientific, naturally follows the loudest signals. A volcano that stirs dramatically gets watched. A volcano that sits quietly, even if it is enormous and still hot beneath, tends to fade into the background. The third reason is the geothermal industry itself. Because the region is so heavily developed for energy, much of the activity there, including the constant small earthquakes, is associated in people's minds with the power operations, rather than with the underlying volcano. The human industry has, in effect, overwritten the natural story. When people hear about seismic activity in the area, they tend to attribute it to the energy production, not to the giant slumbering below, and so the volcanic nature of the place recedes even further from public consciousness. The result of all this is a strange and unsettling situation. one of the largest and youngest volcanic systems in North America, sitting beneath a populated and economically vital region, capable in principle of significant eruptions, receives comparatively modest public attention and nothing like the fame of its cousins. It is not that scientists are unaware of it. Researchers do study the region and understand its volcanic character. But in the public imagination, and arguably in the intensity of monitoring compared to the famous systems, it is the forgotten giant, watched far less closely than a system of its scale and youth might warrant. And that is precisely what makes it so compelling and so worthy of our attention. Hashtag, the signs of a living system A volcanic system is never truly static. And even a quiet one gives off signals for those who know how to read them. The hidden giant of Northern California, for all its outward calm, bears the marks of a system that is still very much alive, and understanding these signs helps us appreciate why it deserves more watching, not less. The most obvious sign is the heat itself, the extraordinary geothermal energy we have already discussed. That heat is not a relic of the distant past slowly fading away. It is a present, active reality, tapped every single day to make electricity. A system that hot, that close to the surface, over that large an area, is by definition a system with a living heat source beneath it. This alone marks it as fundamentally different from an extinct cold volcano. Then there is the seismic activity. The region experiences a great deal of small earthquake activity, some of it tied to the geothermal operations and the movement of fluids underground, but occurring in a setting that is inherently restless because of the hot, deforming crust beneath. In a volcanic system, the movement of magma and hot fluids, the cracking of rock under stress, and the shifting of pressure at depth all generate earthquakes. A truly dead system falls silent. A living one keeps murmuring, and this region murmurs constantly. There are also the surface expressions of the heat, the hot springs and the escaping gases, and the mineral deposits that betray the circulation of hot fluids through the crust. These are the exhalations of a system that is still breathing, still processing heat and fluid from the depths. And beyond the present-day signs, there is the geological record itself, the physical evidence of past eruptions preserved in the landscape, the domes and flows and layers of ash that tell the story of a system that has erupted repeatedly and in the long view of geological time. Recently, a volcano that has erupted within the recent geological past, that still has a hot heart beneath it, and that still generates seismic and thermal activity at the surface, is not a volcano that has finished its work. It is a volcano between acts. None of this means an eruption is imminent. It is crucial to be honest about that. These systems operate on timescales that dwarf human lifetimes, and long periods of quiet are entirely normal, even expected. But the signs collectively paint a clear picture. This is not a dead mountain. It is a living, breathing volcanic system, hot beneath the surface, seismically restless, and geologically young, sitting quietly beneath a landscape that gives almost no hint of the power below. Hashtag, what an awakening could mean. Let us consider, carefully and without exaggeration, what it could mean if this hidden giant were ever to stir back toward eruption. Because understanding the potential consequences is exactly why paying attention matters. It is important to say clearly that the most likely future for this system, over any span of time we can meaningfully plan for, is continued quiet, or at most minor activity. The catastrophic super-eruptions that define the word supervolcano are extraordinarily rare events, and there is no basis for expecting one anytime soon. But volcanic systems are capable of a wide range of behavior, and even far short of a super-eruption, an awakening of this system could have serious consequences, precisely because of where it sits. Consider first the location. This volcanic field lies not in some remote wilderness, but within reach of populated communities, agricultural land, and, crucially, that enormous geothermal energy complex that supplies a significant amount of electricity to the broader region. It is also not far in the grand scheme of things, from one of the great population centers of the United States. The San Francisco Bay Area, home to millions of people. An eruption of even moderate size in this setting would not be a distant curiosity. It would be a regional emergency. What would such an eruption look like? The nature of the magma in these systems tends toward the explosive. Rather than gentle rivers of lava, an eruption here could involve the violent ejection of ash and gas, the growth or destruction of volcanic domes, and the possibility of fast-moving flows of hot material near the vent. Ashfall is one of the most far-reaching hazards. Volcanic ash is not soft and fluffy like the ash from a campfire. It is made of tiny, sharp, abrasive particles of pulverized rock and glass. When it falls, it coats everything, and it can collapse roofs under its weight. Foul engines and machinery, contaminate water supplies, ground aircraft across vast areas, and pose a serious hazard to the lungs of people and animals who breathe it. Depending on the winds, ash from an eruption in this region could drift across populated areas and disrupt life far from the volcano itself. Then there is the direct impact on that vital energy infrastructure. The geothermal complex that draws its power from the region's heat sits essentially on top of the volcanic system. Any significant volcanic unrest or eruption could threaten this infrastructure, potentially disrupting a meaningful portion of the region's electricity supply at the worst possible moment. The very asset that makes the region so valuable would be directly in harm's way. And beyond the physical hazards, there would be the enormous disruption that any major volcanic event brings. The evacuations, the economic damage to the vineyards and agriculture and tourism that sustain the region, the strain on emergency services, and the ripple effects through a densely populated and economically powerful part of the country. Even a modest eruption, in a place this populated and this important, would be a major event, and the fact that it sits so far from public awareness means that the region might be less prepared for it, psychologically and practically, than places where the volcanic threat is front of mind. Hashtag what the rocks remember to understand what a system is capable of. Geologists read the story written in its rocks, and the rocks of this region tell a long and dramatic tale. This is not a place where volcanic activity happened once and stopped. It is a place where molten rock has pushed toward the surface again and again over an extended span of time, each episode leaving its signature in the landscape for those who know how to read it. Scattered across the region are the hardened remains of past eruptions, the domes of thick lava that oozed up and piled high before solidifying, the layers of ash and rock blasted out in more violent episodes, and the flows that spread across the ancient countryside. Each of these features is a chapter in the biography of the volcano, and taken together they reveal a system that has been persistently active, migrating and evolving, producing eruptions of varying styles and sizes across its long life. Some were relatively modest, others were far more substantial, the kind of events that would be regional catastrophes if they happened today. What is most striking is how recent, in geological terms, the youngest of these eruptions are. We are not talking about activity from the age of the dinosaurs, frozen in deep time and long since extinguished. We are talking about eruptions that occurred within a window that geologists consider recent enough that the system cannot be dismissed as finished. In the lifespan of a volcanic field, which can stretch across enormous periods, a gap of quiet lasting many thousands of years is not the end of the story. It is merely a pause between chapters. The rocks remember what the landscape has forgotten, and what they remember is a giant that has erupted many times and is given no geological indication that it has erupted for the last time. Hashtag how a giant wakes if this system ever did begin to move back toward eruption. It would not happen silently or instantly. Volcanoes, for all their terrifying power, tend to telegraph their intentions, and understanding how a giant wakes helps explain why watching it matters so much. The awakening usually begins deep below, with the movement of magma. As molten rock rises or accumulates in the reservoir beneath a volcano, it has to force its way through solid crust. cracking and shouldering the rock aside. This generates earthquakes, and crucially, not just any earthquakes, but distinctive patterns that trained scientists can recognize as the signature of moving magma, different in character from the ordinary tectonic quakes or the tremors caused by industrial activity. A shift in the pattern, the depth, and the rhythm of the seismic activity is often one of the earliest hints that something is changing far below. As the magma pushes upward and the pressure builds, the ground itself begins to respond. The surface can swell and deform, rising by measurable amounts as the reservoir inflates beneath it, much like a balloon slowly filling with air. Modern instruments and satellites can detect this uplift with astonishing precision, catching movements far too small and slow for any person to notice by eye. At the same time, the volcano's breath changes. The gases escaping from the ground can shift in their composition and volume as fresh magma releases the gases dissolved within it. And a rise in certain volcanic gases can be a telltale sign that new molten rock is entering the system. The heat can intensify too, altering the behavior of hot springs and geothermal features at the surface. Individually, any one of these signs might mean little, since living volcanic systems fluctuate all the time. But when they begin to appear together, building and reinforcing one another, swelling ground and shifting earthquakes and changing gases and rising heat, they form a pattern that scientists have learned to take seriously. This is the language in which a volcano announces that it is stirring. The entire purpose of monitoring is to be fluent in that language, to be listening carefully enough to catch the first sentences of the warning. And that is exactly why a system, left less watched than it deserves, is a system whose first words of warning might go unheard. Hashtag. The danger of not looking here is perhaps the most important idea in this entire story, and it has nothing to do with predicting doom. It is about the simple, profound value of watching. The great tragedy of many natural disasters is not that they were unpredictable in principle, but that the warning signs were not being watched closely enough, or were not understood in time. Volcanic systems, unlike some hazards, often do give warning before they erupt. They swell as magma rises. They shake more intensely and in telltale patterns as molten rock forces its way upward. They release different gases in different amounts. They heat up. A well-monitored volcano is one where these signs can be caught early, interpreted correctly, and acted upon, giving communities precious time to prepare and, if necessary, evacuate. The intensive monitoring of famous systems like Long Valley and Yellowstone is exactly what gives scientists confidence that they would likely see a major eruption coming, with enough lead time to save lives. But a system that is watched less closely offers less of that protection. If the hidden giant of Northern California receives less attention, fewer instruments, and less public awareness than its scale and youth deserve, then the margin for early warning is thinner. The signs might still come, but the question is whether enough people are watching to catch them, to interpret them, and to sound the alarm in time. This is the real danger of not looking. It is not that the volcano is more likely to erupt because we ignore it. The Earth does not care about our attention. The danger is that if it does begin to stir, our inattention could cost us the very warning time that might otherwise save countless lives and allow for an orderly response. This is why the story of the second California supervolcano matters, not as a source of fear, but as a call for awareness. The systems we watch, we can prepare for. The systems we forget, we leave ourselves vulnerable to. And a volcanic giant sitting beneath a populated, economically vital corner of one of the most important states in the country is exactly the kind of thing that deserves to be watched, studied, and understood, precisely so that it never catches us by surprise. Hashtag living above the giant, step back for a moment and consider the strange reality of what we have uncovered. Beneath the peaceful hills of Northern California, beneath the vineyards and the oak forests and the placid lake, beneath one of the greatest clean energy resources on the planet, there sits a living volcanic system, young in geological terms, still hot, still restless, and capable, in principle, of eruptions that could reshape the region. Millions of people live, work, and vacation within reach of it, and the overwhelming majority of them have never even heard its name. They know the region for its wine, its beauty, its renewable power. They do not know it for the giant that lies below. And here is the thing to hold on to. This is not cause for dread. The people of that region are not living on borrowed time in some imminent sense. And the sun will almost certainly rise on countless ordinary, peaceful days there for generations to come. Volcanic systems move to their own vast, slow rhythms, and quiet is their most common state. But there is a meaningful difference between quiet that is watched and understood and quiet that is ignored. The first is a kind of readiness, a relationship with the land that respects its power and prepares for its possibilities. The second is a gamble, a decision, made mostly by not deciding at all, to look away from something enormous simply because it has not yet demanded our attention. The famous supervolcanoes, Yellowstone and Long Valley, have earned their fame and their monitoring, and that is exactly as it should be. But fame is a poor measure of danger, and obscurity is no measure of safety. The hidden giant of Northern California is a reminder that some of the most powerful forces on Earth do not announce themselves with dramatic peaks and famous names. Sometimes they hide beneath gentle hills and quiet lakes, betraying their presence only through the heat that rises from below and the occasional murmur of the restless crust. The steam that turns the turbines is the giant breathing. The small earthquakes are its heartbeat. And the question is not whether it is there, because the evidence tells us plainly that it is. The question is whether we choose to watch it, because in the end, the most dangerous volcano is not the largest, or the hottest, or the youngest. It is the one that no one is watching. And for now, sitting quietly beneath the beautiful, unsuspecting hills of Northern California, that may be exactly what this second great supervolcano is. Not a monster about to devour us, but a sleeping